Going to do that electrostatic potential, that is potential due to a point charge. See, suppose consider a isolated charge plus Q at A. This gives electric field in all direction, right? Now direction of the electric field in this direction. Now my aim is to find potential at this point, particular point. What is the potential at this point? The point is at a distance of r from a given charge, right? Now you have to write consider, see, this is level A, right? See, consider an isolated point charge, important, isolated point charge plus Q kept at A, producing an electric field. Let P is the point at a distance of r from the given charge, where electric potential or potential has to be determined. Let r is some point which is at a distance of x from the given charge. Let r is some point at a distance x from A. If you keep a unit positive charge here, what will happen? It experiences a force. This is force acting on a unit positive charge. Now this charge I will displace through a small distance from r to S, through a small distance dx. I am doing a small amount of work. This work is done against the field direction. Work done is against the field direction. Therefore, let an unit charge of plus 1 coulomb is kept at F, at R, is shifted through a small distance dx against the field direction, against the field. Therefore, what is the work done? Work done on the charge, the unit charge, is equal to force into displacement. Therefore, small amount of work done against the field direction is equal to force into displacement. Now, how to calculate the force? The force is equal to 1 by 4 pi epsilon naught, 1 by 4 Q1 and Q2, that is Q1 and Q2, Q1 and Q2 by square of the distance, right? That is 1 by 4 pi epsilon naught Q by x square. Now what is that? Suppose if you keep a positive charge here at infinity, it will not experience any force, which is far off distance. Then what is the total work done? What is the total work done in bringing the unit positive charge from infinity to this point against the field direction? This is nothing but the definition of potential at the point. Therefore, the total work done in shifting shifting the unit charge from infinity to the point P against the field direction, right, is equal to, this is what total work done against the field direction from infinity to that point. This is same as potential by definition. See, by definition it is same as potential at P. Potential at P due to charge Q. This is the definition of potential. Therefore what? Minus infinity to R. BW is what? F dx. What is F? F is equal to 1 by 4 pi epsilon naught Q by x square. Fi substituted here. Next, this dx, don't forget to write this dx. Now you have to evaluate. Here minus is there, minus I have taken. 1 by 4 pi epsilon naught is a constant. Charge is also constant, you are taking it out. Here you see, the potential at the point is equal to minus 1 by 4 pi epsilon naught. Q also have taken integration of infinity to the point R dx by x square. This portion you can easily calculate. This is what integration of minus c x square dx. Take to the numerator here. Infinity to R. This is x to the power of n, integration of x to the power of n. Dx is equal to x to the power of n plus 1. N plus 1. That formula you know. That is x to the power of minus 2 plus 1. Minus 2 plus 1. Infinity to that point R. Therefore x to the power of minus 1 by minus 1. R and infinity. That is equal to 1 by infinity, it goes by x. R and infinity. Then what is it? This I am substituting here. What will get? Potential at the point to minus 1 by 4 pi epsilon naught. Q is there. And this portion is what? Minus 1 by x, R and infinity. Minus and minus plus. You bring this side. Therefore 1 by 4 pi epsilon naught charge 1 by x, R and infinity. You substitute upper limit minus lower limit. This is 1 by R, this is 1 by infinity, right? 1 by R minus 1 by infinity is 0. Therefore, you are remaining with, it remain only 1 by R. The potential at the point is equal to 1 by 4 pi epsilon naught. Q is 1 by R. Or else you can write potential at the point is equal to Q by R. Understood? This is work done is what? Joules per coulomb. Or joules per coulomb is also called volt. Now, on the same line, what is the relation between electric intensity and potential difference? See, this is a relation which we are going to, they will ask you for 3 marks. Here, what you have to remember now, they may ask you for 1 mark, that definition of potential. What is potential difference? Define what is that? 1 volt if they ask. How to define 1 volt? If 1 joule of work is spent in bringing a unit positive charge from infinity to that point, then the potential at that point is said to be 1 volt. If the total work done by shifting the charge from infinity to that point against the field is 1 joule, then potential at that point is said to be 1 volt. And what is the potential difference? Potential at the point. It is the total work done in shifting a unit positive charge from infinity to that point against the field. This is 1 mark. Now you are writing force into displacement. Force into displacement. For this it carries 1 mark. And description of this 1 mark. 1 plus 1 plus 1. This entire integration you are doing, it is not. This is 1 mark. They may ask you to define this, or the same problem they may ask you for 3 also. It may be 3 mark or 4 mark or 5 mark. It depends how they will do it. And this is 3 mark. What is the relation between electric intensity and the potential? Right? This is what negative electric intensity, called negative potential gradient. Remember, what is gradient? Something changes with respect to distance, or sometimes it is also called electric intensity is equal to negative change of potential with respect to distance. Like that also is possible. You can they may ask you for this one. What is the relation? This is 3 marks. I will do it now. So they may ask you, obtain an expression for, say, suppose on charge Q1 is kept here. Another charge Q2 is kept at a distance of R. Then what is the potential energy? Potential energy of the system. Now, this is what is the potential energy of the system? Potential energy of the system is equal to 1 by 4 pi epsilon naught Q1 Q2 by R naught R square. This you have to derive. They may ask you expression for electric potential energy of a system of 2 point charges. See, point is important. Point charges. The two what? In absence of electric field, they'll ask. In absence of what? See here, consider charge Q1 at a point A, right? Therefore, you consider another point B, which is at a distance of R from the charge A. Therefore, potential at B due to Q1 is equal to what? This is V1. That is what potential at B is what? 1 by 4 pi epsilon naught into Q1. This is, what does it mean? That means it is the work done in bringing a unit positive charge from infinity to that point. Correct? Work done in bringing unit positive from infinity to that point. Suppose this V1 is equal to 5 joules, say 5 volt. That means you have to spend how much? 5 joules of work you have to spend from bringing a 1 coulomb of charge from infinity to that point. If I bring 2 coulomb, that is another 1 coulomb, that is 2 coulomb. What is the work done? For 1 charge, unit charge 5 coulomb, 5 joules. For 2 charge, 10 joules. Understood? Therefore, what is the work done? Suppose there is a charge Q. what is the work done, total work done in shifting this charge from here to here. That means so much joules, right? That is the work done per unit charge. Work done per is called potential. You know that, right? Work done per unit charge. So what is the work done? Work done is equal to P1 and Q1, remember. Understood? Now how to start with? Consider a charge Q1 at A. It and consider another point B at a distance R from A. Therefore, potential at B due to the charge Q1 equal to V1. Understood? What is this? This is same as work done in shifting a unit charge plus C from what? Infinity to B. Now what is the work done? You know that is work done per unit charge, right? Work done per unit charge is V1. Then what is the work done in shifting some charge Q2 from infinity to B. That is called, for one charge, for 1 plus 1 C plus C, this much, plus Q2, Q times of that. That's therefore work done is equal to what? P1 times Q. For 1 coulomb, 5 joules. For 2 coulomb, 10 joules. That means 2 into, for Q2, how much? Q2 times that. Right? This is like 5 joules. This is 5 into Q. Like that. Therefore, we substitute here. V1 is equal to 1 by 4 pi epsilon naught Q1 and Q2. Therefore, this is same as what this work is stored. This work is stored in the charges as potential energy. Okay. Therefore, they may ask you this for 3 marks also. Okay. This is also 3 marks.